Welcome back everybody. So how's you all doing? So in today's video we will cover matrix properties. Firstly we will talk about multiplication of two matrices, then we will talk about commutative law, then associative law, and then what is a identity matrix. So let's move on. So first of all, let's see what happens when a matrix is multiplied with another matrix. So let's take example of 2, 3, 4. Then 1, 2, 3, and let's say 0, 1 and 2. So this will be multiplied with another matrix, say, so this is a 3 by 3 matrix. So this matrix must have 3 rows and the number of columns may vary. This is because only these type of matrix are only multiplied when these two things are same. This is because let's see 1, 2 and 3, and let's say 0, 2 and 0, and 3, 4 and 5. So this is the 3 cross 3 matrix. So what happens if we, let's say, try to multiply a 2 cross 2 matrix with this? So this will be a wrong, since this whole column will be multiplied by this whole row. That means first element of this will be multiplied to the first element of this, then second element with the second one, and third will be the third one. So what happens that this can be a 3 cross 2 matrix where n equals to 2 or 3 or maybe 1. So this may vary. So that's the general rule. So let's erase this. So let's take it a 3 cross 1 matrix, 1, 2 and 3. So let's erase this also, and it's alright. Now what we do with the multiplication is that 2 will be multiplied, 1 will be multiplied by this 2 will be multiplied by this 1, and 3 with 0, and similarly with the next row, then again with the next row. So this will be a 3 cross 1 will be our new matrix. So let's see how we will find out that. So we know that this will be a 3 cross 1 matrix. So now 1 multiplied by 2, addition with 2 multiplied by 1, that is 2, and 3 multiplied by 0, 0. So this will be a 4. Then next row, so 3 plus 4 plus 3, that will be 6 plus 4, 10. So this will be 10. Then 4, 6, 10, and 6, 16. So this will be our new matrix, 4, 10 and 16. So this is a matrix versus matrix multiplication. I hope you all would have get that. If you want another example, then 2, 3 and 4, then similar things will be happen to this, and those will be written here. So that's not much. But in case of commutative law, you know what that means is a multiplied by b must equals to b multiplied by a, or in the case of addition same. But in case of associative law, a cross b bracket cross c. So this will be equals to, if we write it like this, a multiplied by b multiplied by c. So this is our associative law. And in the case of matrices, let's just check out that if these follow the rule or not. So let's see, Let's take a small example. 1, 2, 3 and 4. So this is the first one, then 2, 3, 4 and 1. First we will check out about commutative law. So this will be 2 plus 6, 8. 8 will be written here. This multiplied by this and then this. So wait a minute. So now what we will write next is that 2 multiplied by 4, 2 multiplied by 2, that is 4, 4 plus 12, that is 16. So this will be 16. Then next 7, 4, 1, 3, 1. Now again 4 to the 8 and then 4. Then 8 plus 4, that is 12. So this will be our matrix. But what happens if we interchange them? So that will be 2, 3, 4, 1 with 1, 2, 3 and 4. 1, 2, 3 and 4. You can take with any example you want, but the whole thing will be same. It can vary in some examples but not in all. So that's the general idea. So this will be 2 plus 8, that is 10. Then 3 plus 2, 5. Then 6 plus 16, that's 22. And then 6 plus 4, that's 10. So as you can see, the both things are different. So that means it doesn't follow commutative law. 2, 0, 1, 1. And I will just make them, the numbering will be changed only, like 1, 1, 0 and maybe some numbers to make it easy, because that will be a lot of calculation and I do not want to do that, because that will be a very hard work. And here I want to just prove that to you. So that's all, so that you can understand easily. So first of all, let's multiply these two. So that will be a 2 and 0. Now wait a minute. And here it will be a 2 and 3, 5. And the downside it will be 3. So now let's take this 1, 2, 0 and 2. So this will be equals to 2 plus 10, 12. And the downside it will be 6. And above it will be now 10. And the downside it will be 6. So this is our answer for the first one. Now let's see what will be the multiplication for the downside. The other two parts will be now multiplied, so let's put them in curly brackets. So the multiplication, so first of all is 2, 0, 1 and 1. Now this will be multiplied by, here it will be a 3 and downside it will be 6, and above here it will be 0 and 2, and lastly it will be 6. So now if I do this, 3 to the 6, 6 plus 6, 12, that is true. Now downside it will be 6, because 3 multiplied by 0, 0, and 6 multiplied by 1, 6, that will be here. Now finally 4 plus 6, that is 10, it's true. Now finally it will be 6 again. So this proves that the matrices are not commutative but associative. So I have just proved this. Now let's move on to our final topic, that is identity matrix. So what's that? So it will be something like this. This will be a case of square matrix. So this will be something, if I generalize it, wait a minute. So it will be something like 1, diagonally it will be 1, and the rest of the elements will be 0. So you can understand this. And similarly here, this will be a 0, then 2 zeros, then 3, and so on. So this will be our identity matrix where the diagonals will be 1 or same number, can be 5, all the diagonals will be 5, but that doesn't matter because when we took out 5 from them, that will be similar. But if there is something like 2 here, 2 here, and so on, 2, 2, instead of 1 there is 2 in the diagonal, then if whenever we took out any element, same element, which is the multiplication in the every elements of this, so maybe if here it would be 2, 2 and 4 and 4, then when we took out a 2 from this row or a 2 from the column, then that will be here and the 2 will be deducted from every element. But in this case, that's another matter, since here only a single 2 is there on every row. So when we took out a 2 from them, that will be 2 to the power n. The number of elements in the diagonal are present, that will be n. So I hope you would have understand the identity matrix. That's very important, since two identity matrix when multiplied, that gives a identity matrix. So let me write just here I dot I equals to I. So let's follow the commutative identity, and when I multiply by I cross I, that dot is just multiplication, multiply by I, that will be again I. So that's very funny. I like the jokes that come out from this. These are the jokes which my teacher told me once. So I multiply by I will be a I, and I for I. So that's all for today. And before you leave, our channel is growing and we are very nearby to reach 150 subscribers. So I appreciate your all performance in this, and I hope you all will continue to support us. And about the neural network and deep learning, I have given the overview what I will discuss. So the videos will be coming adjacently. So first one from machine learning, then from neural network, and the common topics will be discussed in any of them and will not be taught in others, since to save the time and to gain more and more knowledge. So be sure to subscribe to our channel and like this video and share this video with your friends if you like it. So thanks for watching and see you in the next one.